So essentially, the two cars at some instant of time are parallel to each other, and at that instant of time you start your clock. There's one car which is traveling very fast, so that car essentially gets a head start. The second car only starts to move after some time interval. So the policeman car starts to travel after some time, okay, and then the policeman car eventually reaches a speed higher than the speeding car, overspeeding car, and eventually the policeman presumably is able to catch up. Okay, when they catch up, the distance moved by the policeman should be exactly the same as the distance moved by the speeder. Okay, so in these questions, it's always nice to be able to at least sketch quantitatively what's going on. That in other words just means that you have to plot the graph of a function. Okay, and which, so you can plot on the position time graph, you can plot the speed time graph, you can plot the acceleration time graph. Which of these graphs you bother to plot depends on what information is given to you. The information that is given to you in this question is the speed time, is related to the speed or the velocity. So that's the graph that we should plot. So let's plot. Okay. So you have V versus T. You can do it without the plot as well, of course, except that it becomes safer if you do it with the plot, because then you are less likely to make any stupid mistake. Okay, so you have the speeder. The speeder is easy. The speeder velocity remains constant throughout. So you just get a flat horizontal line. Let's call the value of that Vs. Okay, Vs, of course, we can work out the numerical value of Vs. That's 140 kilometers per hour, and can work it out numerically. This is, you need to be good at unit conversion. This is that he travels 140 kilometers in 1 hour, and this is equal to 140 multiplied by 1000 meters divided by 3600 seconds. So if you work out this fraction, you'll get the answer in meters per second. Okay, so you need to be good at doing this simple unit conversions. Okay, anyway, so you have that this blue line is giving you the velocity time graph for the person who's doing the overspeeding. So this is the origin over here, 2c, and you also have then the policeman who's giving chase. The policeman, of course, doesn't start to move until some time later. So the policeman's velocity remains 0 until some time, let's call that Td. And then the policeman accelerates uniformly. That means that the velocity time graph after this time should be a straight line. That's what uniform acceleration is. Remember, this is velocity time. That's why it's extremely important to label your axis. What are you plotting? Don't draw any graph without labeling the axis, because if you don't label the axis, how do I interpret it as? Is it position time? Is it velocity time? Is it acceleration time? They're all three very different things. Okay, so this is uniform acceleration. Its speed increases, so this goes up. We know that this goes beyond the blue line because the final speed of the policeman is greater than the speed of the person who's doing the overspeeding. Okay. Right, and this let's just call it Vp, and then thereafter the speed of the policeman is constant. Let's call this time Tf. We also know the value of Tf because Tf minus Td is 20 seconds. Okay, so knowing that Td is 15 seconds, Tf is 35 seconds. So you know Td, you know Tf. You know Vp, you know Vs. So that's good. Okay, you know almost everything that there is to know over here, except that many of these physical quantities that are being asked, you have to translate these to positions, not speeds. Okay, so the very first part says what is the distance between the speeder and the police cruiser when the police cruiser starts. So police cruiser starts at this time. During this time interval, of course, they were parallel to each other at this time. But during this time, the police cruiser remained at rest, but the overspeeder just kept on going. So the distance by which the speeder is ahead essentially is the area, this area. It's essentially Vs times Td. So in other words, you can chop up this time interval into small slices, calculate the area of each time slice, that is basically the distance moved during the time slice, put all these time slices together, of course you get this rectangle in this case. And that area of this rectangle is just Vs times Td. So part A is just Vs times Dd. That's the distance by which he is at. Of course, plug in numbers and you'll get the answer, but that is trivial, okay. Part B, what is the distance between the speeder and the police cruiser at the instant when the police cruiser attains the uniform velocity of 150 kilometers per hour? Okay. So a common point of confusion, but that will come in later. This is essentially that, okay, how much distance is there between the policeman and the overspeeder at this instant of time? At the time until because this is a time at which the policeman attains the velocity of 150 kilometers per hour. So it's essentially the same thing as the previous part, except the previous part was particularly simple because the policeman hadn't even moved. In this case, the policeman does move, but you just have to subtract the two values, the distance moved by the overspeeder, distance moved by the policeman until time Tf. For both, take the difference. That's the separation between them. Okay. So the distance moved by the speeder, of course, is Vs times Tf. This should be bigger, of course, because the policeman still has not caught up to the speeder. Okay. Minus you have to do the distance moved by the policeman, which is this distance. And this area corresponds to that distance, and this area equals half times Vp times Tf minus Td. That's your part B. Of course, over here there are many different pitfalls. There are many different. Of course, your talent knows no bounds, but there are many different errors that students commonly make. Okay, so I should point out those errors so that you don't end up making them eventually. Okay, again, your talent knows no bounds. So anyway. One common error is, of course, well, sir, the policeman attains a velocity of 150 kilometers per hour in 20 seconds. We can figure out, and it's uniform, so we can figure out the acceleration of the policeman, and the policeman starts from rest. So the distance traveled by the policeman should just be half times A times Tf squared. That's what the distance traveled by the policeman should be. So if you want to write that down, you write half times AP. AP is the acceleration for the policeman during the acceleration phase, of course. XP is the distance moved by the policeman during the acceleration phase, and you just write T. You just say this is X is equal to X naught plus UT plus half AT square. The policeman starts from rest, the policeman starts from the origin, X naught is 0, U is 0. You're just left with half AT square. You calculate this number, this is not at all the same as this number. So what went wrong over here? You have Tf minus Td whole square. That's what should go into the time over here. Why? Because the policeman is essentially starting from Td, is starting moving from Td. Okay. Well, so okay, another way to phrase that would be you write down this, right? That this describes the position of a moving object with constant acceleration. Why does this fail? This contains no Td. Why all of a sudden did you have to include Td? Why don't you see any Td or T naught or anything like that over here? There's an assumption, you're close, there's an assumption built into deriving this equation. Beyond that, yeah, beyond that. when you derive this, you integrate it, right? You integrated the velocity from some time until time t. From what time did you integrate? 0. You essentially were assuming that the object starts moving at time 0. This equation is only true when your object starts moving at time 0. Of course, this is not true for the policeman. That's why this equation breaks down. The policeman only starts moving from time td. If you go back to how you derive this and just change the lower limits of the integrals from 0 to time td, you do get the correct equations. Okay, it's as trivial as that. Okay. Another very common point of confusion is, well, over there you have written down half Vp Tf minus Td. Over here now I know that this should actually be Tf minus Td whole square. This is correct. But yeah, well, doesn't this look different from that? Actually, if you plug in numbers, you do get the same number. They're actually fine. They only look different because this contains AP, this contains VP. This is constant acceleration over a time interval Tf minus Td. You can apply V is equal to U plus A times the time interval. Again, you have to take into account that when you do the integration, the lower limit is not 0. The object does not start moving at 0. The object starts moving at time Td. So what you will get is U plus A times Tf minus Td. This is what you will get as V. Not just V is equal to U plus At. So U is 0 for the policeman, and A is of course AP for the policeman. You plug this thing over here and you get that. Okay? So always make sure there's always, whenever you apply V square is equal to U square plus 2AX, X is equal to X naught plus UT plus half AT square. V is equal to U plus AT. There's a very strong built-in assumption over there. Your object starts moving at the instant when you start your clock. Okay? If it doesn't start moving when you start your clock, take that into account, as you did just for the policeman. One easy way to take that into account is to sketch graphs. For example, if the policeman has started to move at t is equal to 0, that's essentially what the policeman graph would look like. Because there's a time delay, this whole straight line gets shifted td units to the right. So in V is equal to U plus AT, for example, instead of t, you write t minus td. That's one way to derive it. Basically, it's equivalent to essentially taking the different lower limit of integration into account. Okay. Right? And now, so part B is done, but I gave you some warnings. Okay, don't make these common mistakes. Okay. Again, many times you learn more from your mistakes than doing the right thing. Okay. Part C. How long does a police cruiser take to catch the speeder? So when the policeman catches the speeder, their value of x for both objects, the value of x is the same. There's a very, very common mistake that people make. They say, okay, let's find out this time. This is some value of time, but at this instant of time, the speeds are the same, not the positions. The policeman is still behind the cruiser at this instant of time, because before this time, the speed of the policeman was always less than the speed of the speeder. So obviously, when an object's speed is always less than the speed of some other object, that object has traveled a smaller distance compared to the other object. Of course. So therefore, the policeman until this time has traveled a smaller distance than the speeder. So there's no way that the policeman has caught up to the speeder. It's only that after some time interval during which the policeman's speed is bigger than the speeder, can the policeman have any hope of catching up to the speeder. Okay. So how do you do this? Well, power of algebra. You say there's some value of time at which they are able to catch up. Let's call that capital T. find out in terms of capital T the distance moved by the speeder, the distance moved by the policeman, set them equal to each other, solve for capital T. Okay, so the distance moved by the speeder is very nice, okay, Vs times capital T. And this is equal to the area of this shaded triangle that you have already kind of done. You don't, if you calculate this number, you don't need to calculate it again, but since I haven't, I'll just write it again. So you have Vp times Tf minus Td plus this shaded area. This is easy as well, because during this phase, the policeman is traveling at constant speed. So this is Vp times capital T minus Tf. That's the only condition I have. That's the only equation I have. Whenever you have an equation and your hope is of figuring out some numerical value from an equation, always count how many unknowns do you have. If you have one equation, you better have only one unknown. If you have two unknowns, you better search for another equation. Okay? So, how many unknowns we have? T, capital V, okay, so Vs I know. Let me put a tick mark on things I know. Capital T I don't know. Half of course I know. Vp I know. Tf I know, Td I know. Vp I know, Tf I know, capital T I don't know. So there's only one thing I don't know in this equation. I can solve for that. This is a very simple linear equation, essentially no more difficult than this equation. Solve for x. It's basically the same thing. Okay, so just solve for capital T, and again make sure that your numerical value makes sense. Maybe you got some sign wrong. Capital T should be bigger than 35 seconds. If you made some mistake, it's very likely you'll get some answer, nonsense answer like minus 10 seconds or minus 15 seconds or 21 seconds. Okay? Yeah, exactly. कौन सा velocity की difference है? आप इसको अगर velocity की difference से divide करते थे, answer B को. Answer for B is the relative velocity. Yeah, that's. But I haven't talked about relative velocity. Okay. Okay. Question 2. Right. Question 2 is very straightforward. That's just a simple exercise in vector manipulation. So you have 2ex plus 3ey plus ez. So A is a vector in 3 dimensions. So 2ex plus 3ey plus ez. It's one ez, but one ez is just ez. The ez is the unit vector in the z direction. So basically in 3D, you have x-axis, you have the y-axis, and then you have the z-axis that is coming out of the board. And then the negative z-axis is of course pointing into the board. Okay. So Ez is the unit vector that is pointing out of the board. Ex is pointing like that. Ey is pointing like that. Any vector in 3-dimensional space can be written by using these building block unit vectors. Okay, because any vector along the x-axis, any arrow along the x-axis can be written as some multiple of Ex. Any arrow along the y-axis can be written as a multiple of Ey. Any arrow along the z-axis can be written as a multiple of Ez. If you can draw any of these 3 arrows, if you can draw any arrows that point along these axes, any other vector is a sum of these 3 arrows. Okay, that's what we mean by that. Okay, a point has coordinates x, y, z. That means moves this much distance along the x-axis, move this much distance along the y-axis, move this much distance along the z-axis. You reach that point. Okay, right. And you are given a third vector then, second vector, b is equal to minus ex plus 2ey plus bz ez. Bz you don't know. Okay. You first of all, there's a resultant vector. Resultant vector is just the result of of vector addition or vector subtraction. Okay. In this case, resultant is just a plus b. And if you have vectors written down in unit vectors, using unit vectors, it's very straightforward. You just treat ex, ey, ez as ordinary algebraic symbols, add terms that contain Ex together, add terms that contain Ey together, and so on and so forth. So if you add them, you get 2 minus 1, 1. So you just get Ex. 3 plus 2, 5. Very profound things. And 1 plus Bz. Again, be very liberal in your use of brackets. I have seen this too many times to count. Okay, this is nonsense. Because this is, what is this plus 1? This is correct.
Last time we used hat notation for the.
Yeah, you can use hat. Okay, so you can.
So in paper, if you do not write anything, will it work?
What do you? Then you have to write something for unit vectors. Okay, you can use. You can use I hat. You can use j hat. You can use k hat. Yes. You can even write, let the unit vector along x, but write it down. Let the unit vector along x be Salma. Let the unit vector along y be this. Okay. So at least I know what your language means. Okay. Just like you do in programming, right? You can use any variable name. But as long as it's clear, okay, as long as you comment, okay, this variable name stands for this, okay. So if somebody can reasonably understand, invent any notation for the unit vector, that's fine, as long as you define it. Okay. But again, the advantage of this is that these notations are standard enough that you can get by without defining. It's kind of understood क्या मतलब है.
Sir, I J और K पर hat ना लगाने का मतलब.
नहीं मसला है उसका. Okay, because without the hat, look, without the hat, you'll आपके लिए मसला मान जाएगा. Without the hat, very commonly you may be confusing it with some algebraic symbol, not a vector. Okay, बहुत जल्द फिर हो सकता है आप j को k से मल्टीप्लाई कर दो.
नहीं actually because A level के अंदर जब हमने vectors पढ़े थे तो direct बगैर hats के किए.
वो बड़े simple problems कर रहे होते हैं. It's much more likely to make a mistake if your solution is 1 page long compared to 2 lines long. So it's much more likely that along that 1 page long calculation you will end up multiplying I with j, where there is no such multiplication. Okay. वो तो क्योंकि वो टाइप कर रहे हैं ना. If you're typing it out, then they make it bold font. So yes, you can, for example, I suppose you could do it, okay, but I'm saying just because freshman level classes, the chance of you making an inadvertent mistake is much more likely. Okay, so you're much safer if you do put a hat on top. It doesn't take a lot of time. आपके calculation इतनी भी लंबी नहीं होनी कि you'll be saving a lot. It's a similar thing later on for those of you who will be learning quantum mechanics. अब quantum mechanics कोई operator होता है. अब operator में कई books जो हैं वो कोई operator उसके ऊपर hat डालती हैं. Just to specify कि operator है, that this is a special object known as an operator. Later on, जब आप बड़े हो जाते हो, जब आप PhD level पे, nobody puts these hats. It's kind of तब तक आप बड़े हो गए कि the context is sufficient for you कि आप वो बोंगियाँ नहीं मारने लगे. लेकिन जब तक आप सीख रहे हो, it's very likely कि आप बोंगियाँ मारोगे. So just to prevent trivial mistakes from occurring, it's just to play safe. कि hat डाल दो at the beginner level. Okay. I won't deduct it, okay? क्योंकि आप गलती नहीं गा रहे होगे, of course, okay? Right? So you don't have to put on a hat but it's just to play it safe, okay? Put it, okay? Oh, अच्छा आ रहा हूँ यार उसके लिए, okay? Thank you. Okay. So first of all, मैं resultant discuss करना. What do you mean by the resultant of a vector? Resultant तो कर ले. What do you mean by the magnitude of a vector? Essentially the size of that vector. Essentially you find that out using Pythagoras theorem because your axes are perpendicular to each other. The size of an arrow is essentially the x component square. It's simplest to see it in 2D. You have this arrow. If I know this number, which is ax, if I know this number, which is ay, ax square plus ay square, because this is 90 degrees, that's what I meant, that the axes are perpendicular to each other. That means that immediately implies that this angle will also be 90 degrees. Ax square plus ay square will just be the length squared of this arrow. So you figure out the magnitude essentially using Pythagoras theorem. You take each component, square each component, add that all up, take the square root. Okay, that's the resultant of your vector. Okay, so the resultant, so that's the magnitude of a vector. So the magnitude of the resultant over here is, this component over here is 1. So you are doing 1 square plus 5 square plus 1 plus bz whole square. Again, whole square. People love to make everything linear. Sine of x plus pi by 2 is sine of x plus sine pi by 2. ln of 1 plus x is ln 1 plus ln x. हर चीज एक्सपेंड हो जाती है. Okay, not true. Okay, so similarly this is not 1 square plus bz square. There's also a cross term. Okay, of course right now this might seem trivial, but if you're doing a long calculation, these little steps are exactly where people mess up. Okay, especially after 2 hours of a long exam, your mind is tired, then you're more likely to make stupid mistakes like that. Okay, but anyway, so this is 26 plus 1 plus bz whole square, and this is equal to the resultant. The magnitude of the resultant is 6. So this gives you the square of the resultant. So this should be equal to 36. Okay, because when you take the square root of this, then you'll get 6. You square both sides, you get rid of the square root, so you get 36. Okay, so then what you have is 1 plus bz whole square is equal to 10. And now when you take the square root, you get 2 possibilities. And so bz should be square root of 10 plus square root of 10 minus 1 or minus square root of 10 minus 1. That makes sense, right? You get different possibilities. Because, for example, this vector and this vector, for example, have exactly the same size. If I know the x component and I just give you the magnitude, you have 2 possibilities. You have this arrow and you have this arrow. Both have the same size. Both have the same x component. So that's why you're getting this plus minus. Okay, question 3. Again, question 2 and question 3 really, you should be very, very comfortable with those, because this is the bread and butter of simple vector manipulation. Okay, so you have A and B, their components are given. Okay, so typically we take the unit vectors to be dimensionless. I mean, you could have chosen the other way, but conventionally, you take the unit vectors to be dimensionless, the components carry the dimensions. So if you have a vector that describes position, the components of that position vector carry the dimensions of position, centimeters or meters or whatever, and the unit vectors themselves are dimensionless. Okay, so you have a vector A and you have another vector B. They lie in the xy plane, so let me just make the xy plane. And you have the vector A. Let's write down the vector A. First of all, in terms of unit vectors, what do you write down? 3ex plus 2ey. See? Right? And vector B, yeah, but then again, technically precise, to be technically precise, okay. Right? If I'm asking a question that explicitly asks for, okay, write down the unit vectors precisely, write down the vectors precisely, then better put dimensions. But if you're writing these vectors down as some intermediate step in your calculation, you don't need to be that precise.
Can we write it as 3cm plus ex plus 2cm ey?
Yeah, that's fine, that's fine. I'm just being lazy and want to write cm only once. Okay, so that's it. Okay, anyway. Okay. Just like, for example, you carry out any calculation in your high school as well. You didn't keep track of dimensions. You didn't write dimensions at every step of your calculation. You only bothered to write down the units at the end. The same thing over here. If this is what you need to specify, well, then be careful about the dimensions. But if this is usually, this won't be your question, of course, not as simple as that. These will be part of some intermediate step in your calculation. Okay. Then you don't need to put dimensions. Okay, draw a diagram showing these vectors. So there's the origin over here, right? And then you have vector A. Vector A is, you've already written that down, right? So let's draw vector A. What do I write? Draw, okay, 3 over here. So there's 3 over here, and you have draw something like that. So this is 2, and this is 3. That's vector A. Then I have vector B, which is minus Ex and 3 Ey. So vector B is something like that. And this is 3, and this is minus 1. So this green arrow is my vector A, the yellow arrow is vector B. Calculate the resultant of A and B. Okay, now you can kind of see immediately why this idea of unit vectors is so important and so powerful. If I just had arrows, if I wanted to add A and B, what would I do? Well, one way to do it, okay, first of all I have to shift this yellow vector over here, and then I will be drawing an arrow over here, right? So roughly you'll get something like this, and then you get something like this. Maybe this is a right angle triangle, hopefully. Probably it is not. If it isn't, I have to figure out the length of this thing. For that, I need to first of all figure out what this angle is. I know the length of this arrow. I know the length of this arrow. Then I have to apply the law of cosines. A square plus B square minus 2 times A times B times the cosine of the angle between them, and then take a square root to figure out the length of this arrow. That's a very, very long thing. By using these unit vectors, this is absolutely trivial. A plus B equals what? 3 minus 1? Done. So hopefully you appreciate, why these unit vectors are there to simplify your life, to save your life, rather than you just living in the world of arrows and joining head to tails and so on. Okay.
So by default, resultant means addition.
Yes. Usually it means addition. Yes. Yeah. So just draw the arrow, right? 2Ex plus 5Ey. So that means that your resultant. Yeah, I pretty much got it spot on. This is basically the resultant, and this is basically the result of you translating this arrow over here. So this is your resultant, 2Ex plus 5Ey. That's exactly it. Okay. Okay. The back side contains the really interesting question. Okay. If you understand this one, you really understand vectors. If you don't, well, you need to work harder to understand vectors. Okay. So first of all, you need to explain what this question is talking about. Okay. So there's a coordinate axis, x, y, x-axis, y-axis. So much for that. There's an arrow. Some vector A. Okay. Then there's another pair of axes. X prime and y prime. Of course, x prime, the angle between x prime and y prime is also 90 degrees. This is also an orthogonal or perpendicular pair of axes. Essentially, you can think of x prime and y prime are obtained by rotating this. I take this and I rotate this by an angle, by some angle. That angle by which I rotate it is theta, the angle that the x prime axis makes with the x axis. That is arbitrary. If theta is 90 degrees, then the x-axis essentially becomes then the x prime axis is like that, and the y prime axis is like that.
X prime and y prime can reach 90 degrees yoga.
Yeah, because the original axis is orthogonal. Okay, you can consider these non-orthogonal transformations, but in physics they are usually useless. Okay, is you get the simplest most convenient thing if you consider them to be orthogonal. But in mathematics, in your linear algebra course, you will be considering cases where they're not orthogonal. Okay. Anyway, right. So you have that, and now you see you have the same arrow, this same yellow arrow in both cases. The same yellow arrow can be described in terms of different components. You can describe them in terms of the same yellow arrow has components ax and ay in terms of the axes x and y. The same yellow arrow has components ax prime and ay prime in terms of the axes x prime and y prime. And these numbers can be different. So for example, for x-axis, y-axis, the yellow arrow has a non-zero x component, non-zero y component. But suppose I rotated my blue axis in such a way, this x prime axis in such a way that x prime axis is along this yellow arrow. Then what's the x prime component? No, x prime component. Non-zero is non-zero, right? The yellow arrow is lying along the x prime axis. The y prime component is 0. Of course, it's the same arrow. I did nothing whatsoever to the arrow. But the numbers that go into describing this arrow in terms of unit vectors depends on essentially your choice of unit vectors. Of course, you use different unit vectors, you'll get different numbers that describe the original vector. So in other words, I can write down the vector A is equal to ax ex plus ay ey, exactly what you did in the previous question, except that now you're doing it symbolically. And you can write down the same vector in terms of ex prime and ey prime. Ex prime was, of course, let me just draw it. This is ex prime. This is ey prime. Okay? And this is, let me use some other, I'm out of colors. Okay, never mind. This is ex and this is ey. Okay, right? So you can write down the same vector as ax prime, ex prime plus ay prime, ey prime. And this, of course, has to be equal because it's the same vector. Now the question is asking you, what is the relationship between these four numbers? That relationship, of course, depends on theta. Because if theta is 0, ax prime is equal to ax, ay prime is equal to ay. If theta is 0, you basically do nothing. Your x prime, y prime axis is basically the same as xy axis. But if theta is 90 degrees, for example, then of course you have something different. Because now your x-axis, the original x-axis has become the y-axis, and your original y-axis has become the negative x-axis. The numbers that will go into describing this original yellow arrow are now going to be very different. Okay. This is some kind of rotation, right? Okay. So how do we figure it out? Essentially, it all boils back to that: how do you find out the relationship between these unit vectors? You can see from this, you're going from ex and ey to ex prime and ey prime. If I can write ex prime in terms of ex and ey, if I can write down ey prime in terms of ex and ey, then I can figure out the relationship between these a's. Because right now there's too much changing going on. Everything has become primed. At least get the unit vectors the same on both sides, and then I can figure out, okay, how are the a's changing. Okay. So the first thing I have to do now is to figure out the relationship between ex prime and ex and ey. That's actually very straightforward. So in actual fact, this problem is very, very simple to solve. Okay, it's just that understanding what's really going on is what's complicated. The mathematics is very simple. The mathematics you already know from high school. Okay. So anyway, so if you have a vector, let me take a step back and say, if you have a vector and you know the magnitude of the vector and you know the angle that the vector makes with the horizontal, how do I find out the x component? A cos theta, that's the x component. And what's the vertical component? Make sure you know how to do this. Do not memorize this, that the x component is a cos theta, because this is a very, very common mistake. Why is it a common mistake? Many times, just to mess with everybody, I give this as the angle instead. Then this, of course, becomes a cos theta. The y component now contains the cosine, and the x component contains the sine. But of course, many people have just blindly memorized that ax is equal to a cos theta and ay is equal to a sine theta. Then, of course, they get exactly opposite thing. Okay, so be very careful. Okay, do not blindly memorize it. This just follows from the very definitions of sine and cosine. There's nothing really new over here. Okay, so by the way, from here, given these two equations, you immediately deduce something very interesting. To specify a vector, I can either give you a, aka the magnitude of the vector, and theta, theta tells you about the direction of the vector. Or I can give you ax and ay. If I know ax and ay, I can figure out a and theta. Vice versa. If I know a and theta, I can figure out ax and ay. If I know ax and ay, how do I figure out a? Use Pythagoras. Square both sides of this equation, square both sides of this equation, add. A square is equal to ax square plus ay square. Divide these two equations, a and a cancels, you get tangent theta is equal to ay over ax. So knowing ay and ax, you can figure out a, you can figure out theta, and you can go the other way around. Okay, right. So now the idea is, now I will actually, that was fully general. Now I have x-axis, y-axis. Just focus on this green arrow. This green arrow is Ex prime. My objective is to write, and this angle is theta. My objective is to write this Ex prime in terms of Ex and Ey. This is Ex, this is Ey. So Ex prime equals some number times Ex, because I know that every vector can be expressed as a sum over Ex and Ey multiplied by some number, right? And Ex prime is nothing other than a special vector. So I should be able to write Ex prime also as a sum involving Ex and Ey. And this is some number Ey. Right? This is just a particular example of जो आपने इधर किया है. Except that the vector A is Ex prime. और फिर ये A क्या है? So ये आपका Ex prime है. Okay, and so this is Ax and Ay. Ax equals A times sine theta. But if you are applying this to Ex prime, what is A? A क्या है? Magnitude of the vector A. That's 1. This capital A, if you are applying this whole thing to the unit vector Ex prime, the magnitude of Ex prime is nothing other than 1. So you just have that this thing is cosine theta and this thing is sine theta. This is obvious if you just look at this. This is an arrow of length 1. What would be length of this thing? Cosine theta. What would be the length of this thing? Sine theta. Exactly when we talked about how to generalize the definition of sine and cosine using a unit circle. We already did this. Okay, Ey prime. कौन सा? नहीं, Ex prime तो ये वेक्टर है. Ex prime cos theta equals बस नहीं. First of all, this is not even consistent. The size of the vector on the left hand side is cos theta. क्योंकि इसका साइज तो 1 है ना, इसका cos theta है. So the size of this whole vector is cos theta. The size of the vector on the right hand side is 1. ये equal है, वो कैसे सकते हैं? If you have vector A is equal to vector B, the sizes of both vectors should be equal. Otherwise, सब equal. And moreover, the direction should also be the same. Okay? So there are many ways to check whether your equations make sense. ये कैसे वैसे क्यों लिख रहे हो? Ex prime cos theta या ये वेक्टर है, इसको मैं यानी कि यही चीज मैंने इधर की थी, जब मैंने इधर की थी ये, तब तो किसी से कुछ नहीं बोला। जब मैंने ये एरो ए को मैंने रिप्लेस कर दिया ई एक्स प्राइम के साथ, तो आप सारे परेशान हो गए हो। ओके, ऑल्दो नथिंग रियली चेंज बिटवीन दिस डायग्राम एंड दिस डायग्राम, दिस इज एग्जैक्टली द सेम, एक्सेप्ट दैट दिस इज अ पर्टिकुलर एग्जांपल ऑफ व्हाट आई डिड ओवर देयर। कौन सा किया, दोबारा बताना। ओ ओके, ये अच्छा ये कह रहे हो ये मैं थीटा बनाऊं।
और आपने उस a को cos थीटा से मल्टीप्लाई किया नीचे।
हाँ,
मतलब वो कह रहे हैं कि जो EX है ना, जो लाइन x एक्सिस पे आपने बनाया है, वो बेसिकली अगर हम उस तरह लिखे तो वो EX cos थीटा ही है, जिस तरह वहां पे ये था ना,
EX is a
EX
whole
equals
vector.
to a sin theta
It's a vector in the plane.
हाँ, तो ए जो है इधर ए ये जो ए है, दिस इज जस्ट द मैग्नीट्यूड ऑफ दिस वेक्टर। तो अगर मैं इसको ए लिखूं इधर, ठीक है ए लिख दो, बट दिस ए विदाउट द एरो डिनोट्स द मैग्नीट्यूड ऑफ दिस वेक्टर। तो ये मैग्नीट्यूड ऑफ दिस वेक्टर, व्हेन इफ दिस वेक्टर इज ई एक्स प्राइम, द मैग्नीट्यूड ऑफ दिस वेक्टर इज 1, तो ये cos थीटा क्या आएगा ना, ये उसको गोली मारो। दिस वेक्टर इज दिस इज एन एरो ऑफ साइज 1, दिस इज कंपोज्ड ऑफ दिस एरो प्लस दिस एरो, ये 90 डिग्रीज है, इसकी साइड लेंथ 1 है। What's the length of this thing? Cos theta. What's the length of this thing? Sin theta. Cos theta EX plus sin theta EY will give you this arrow. That's exactly what I've written now. Okay? Make sure that you get this, okay? अच्छा, दूसरा बताओ कि EY प्राइम अब किसके बराबर है? Something 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 EX plus something 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 EY. What is this something something something?
Minus sin theta cos theta.
So if this is theta, ये वाला एंगल क्या है? This should also be theta because the whole axis is being rotated and giving you this. This is 90 degrees, so, and this is also 90 degrees. So if this is theta, this must also be theta. एक पूरी L शेप है, और पूरे L को आपने यूं करके रोटेट कर दिया, जो ये वाली जो आपका आर्म है L का, okay, so essentially this makes an angle theta, this makes an angle theta. Okay, you can also of course do it कि भाई argue कर लो कि भाई angles add subtract करो and you'll find it. Okay, anyway, if this angle is theta and you are now have this arrow to write down in terms of these unit vectors, एक ये तो क्या लिखोगे आप? ये आपका एरो है, ये आपकी एक्सिस है, दिस इज एक्स एक्सिस, दिस इज वाई एक्सिस, दिस इज थीटा। अब बताओ, द साइज ऑफ दिस वाइट एरो इज 1। अब बताओ क्या लिखोगे? माइनस साइन थीटा ई एक्स प्लस कॉस थीटा ई वाई, क्योंकि इधर से अगर आप परपेंडिकुलर थ्रो करो, इधर परपेंडिकुलर थ्रो करो, इसकी लेंथ क्या होगी? साइन थीटा। और ये किसके करस्पॉन्ड कर रहा है? हाउ मच डू यू मूव इन द नेगेटिव एक्स डायरेक्शन, सो माइनस ई एक्स के साथ आएगा ये। और ये क्या होगा? कॉस थीटा, दैट करस्पॉन्ड हाउ मच यू मूव इन द प्लस वाई डायरेक्शन। ओके, सो दिस इज इक्वल टू ई वाई प्राइम इज minus sin theta EX plus cos theta EY. It's very easy to check these relationships. जो भी आपने रिलेशनशिप लिखी है, आपको पता है for one special value of theta what that relationship should be. If theta is 0, EX prime should be EX, EY prime should be EY. अगर आपने गलती से इधर साइन की बजाय cos लिख दिया, cos की जगह साइन लिख दिया है, उसी वक्त आपकी गलती पकड़ी जाएगी। You see, if you put in theta is equal to 0, this is 1, this is 0. So EX prime is equal to EX. But if you had mistakenly put a sine over here and a cosine over here, तो फिर आपका आ जाता है EX prime is equal to EY when theta is 0. That makes absolutely no sense. Okay? Right? You can also check your answer in a different way. अगर theta 90 degrees है, EX prime should be EY and EY prime should be minus EX. डाल के देखो. If you put in theta is equal to 90 degrees, that's exactly what you will get. So it's very, very difficult. You need to be very talented to make a mistake over here, or at least not realize that you have made a mistake. There are so many different cases that you can check. आप सब कंप्यूटर साइंस में जा रहे हो, कोई कोड डिबग करना क्या होता है? You give it different test cases. तो इधर क्यों नहीं टेस्ट केसेस डालते हैं? इधर भूल जाते हो. Okay, so to find out AX, AY इनके दरमियान relationship, what do you need then do? ये जो आपकी EX prime है, EY prime के लिए, plug in the relationships that you have written down. एक ये और एक ये. Plug these in. Then on this side you have things that contain only EX and EY. Over here you also have only EX and EY. Match the coefficients. इधर आप देखो, इधर आप इस क्यों नहीं आप इधर कह सकते थे कि AX is equal to AX prime? Because the unit vectors are different. But now if you plug in for EX prime in terms of EX and EY, EY prime in terms of EX and EY, now everything over here is going to be expressed in EX and EY. Group together the terms and then declare कि जो EX का coefficient है, which is AX over here, should be equal to the coefficient of EX over here. AY should be equal to the coefficient of EY over here. That's it. You have your relationship. Okay, do it. Okay. I'm not doing the algebra in detail क्योंकि सारी ये readings में अच्छी तरह किया हुआ है. But make sure you get this, okay? If you don't get this, there's big trouble down the line, okay?